Is it going? Yeah, it's going.
It is, thank you. And thank you. All right, so now we're on to the next one. H. Oh, I should have just left that. Here we go. Go. Where are we going to draw this one? Well, pay attention, it's a cosine. So cosines are up on the top, but it's a negative number. So where will I draw it? Left side, quadrant 2. Kids, can you ever have a negative number in quadrant 1?
No.
No. So this is not something you even need to think about. That's a negative number. It cannot be here. It must be here. So negative root 3 over 2. That's a 1. How big is the angle right there in the triangle? Well, the angle in the triangle is 30, but some of you already figured out the actual answer is 150. And how did we get that 150? 180 minus the 30. Right? All right, now we've got a couple of tricky ones. Now the tricky ones. All right, I like to think of my numbers as fractions because all of your trigonometric ratios, sine, cosine, tangent, are defined as something over something. So I'm going to make this, it's a 0 on the paper, but I'm going to make it 0 over 1. And then I am going to think about this for a minute. I got to be over here. It's a tangent problem, so I got to be over here. Is it possible to draw a tangent picture where that's 0 and that's 1?
No.
That would not even be possible. When you have a 0, you cannot draw your butterfly bow tie. You have to look at these points. Now, only look at the points that are on the circle, part of the circle that you drew. So I'm not worried about these points over here. I'm looking at that one, and that one. Now, you're saying to yourself, how does she know those are the coordinates? I always let my radius be 1. When I am drawing what's called a quadrantal angle on an axis, I always let my radius be 1. You can let your radius be anything you want and it won't affect your answer. But 1 is the simplest number, so I use 1. So if the radius is 1, I'm going out 1, up 1, down 1 to get these points. Tangent is y over x. Yes, you have to remember that. Tangent is y over x. So you simply go around the circle, and where does it happen that y over x is 0 over 1? Where does that happen here? Up here?
Yeah.
Y over x would be 1 over 0. This is x, this is y, like a regular point. So that would be 1 over 0. That's not what I want. How about this one? 0 over 1? That's it, isn't it? So that's where I want to be. What angle is that? No, that one's 90. This one is 0. That's 0. This is 90, this is 180, and this is 270, remember? So the answer to the problem is 0. Now the next one is another 0. So I am going to look again on the axis. I'm going to look at these points. Right? And I am going to figure out where y over r is 0. Why am I using y over r? Because that is sine. Now the radius is automatically 1. We said that. So I need y to be 0. Where does it happen that the y coordinate is 0? It does not happen at 90. The y coordinate up here is 1. X, y, kids, points. Y coordinate's 1. Where does it happen that the y coordinate's 0? At 0 again. So the answer to the question is 0 degrees. This is the angle where if you put y over r, you get 0 over 1. Well, sine is y. Cosine is x. All right. We got 10 minutes to get through the rest of these. Stay focused. Otherwise, I'll take you into your passing period. Here we go. These look so confusing, but they are very, very easy. They're actually easier than the ones we just did, even though they look a lot harder. Always in math, you've been taught to start inside the parentheses, right? So let's start right here. Let's draw a picture of that. We're over here. Why am I over there? Tangent. Remember, I'm forgetting this. I'm looking just inside the parentheses. Now, shall I draw it in quadrant 1 or quadrant 2? 1, because this is a positive number. Now, this is not 30, 60, 90, or 45, 45, 90. Would you agree? But I can use the Pythagorean theorem to find that third side. We've done that many times. So what's that third side going to be? 5. 3 squared plus 4 squared equals c squared. That's 5. Now, I don't know the angle, but can I find the sine? Yes. What's the sine? 3 over 5. Very good, Ellen. 3 over 5. Sine is opposite over hypotenuse. And this question says, find the sine of that picture. That's it. Easy. Let's look at the next one. Now we're going to find the cosine of this picture. So this is a sine problem, so I'm going to draw it over there on that side. Shall I draw my triangle in quadrant 1 or quadrant 4? 1, because 5/13 is a positive number. So notice how I labeled my triangle. Sine, remember I'm not doing anything with this yet, I'm looking just right here. Sine is 5/13, opposite over hypotenuse. So 5 squared plus b squared equals 13 squared. That works out to be 12. I want the cosine. Adjacent over hypotenuse, the answer to the question would be 12/13. It does not get any easier than that, folks. Let's try the next one. Tangent of the angle whose sine is -4/5. All right. Now it's another sine problem, so it's going to be over here. But this time, what do you notice? It's negative, so I'm going to draw my triangle down here. Alex, you got that? So the sine is -4 over 5, opposite over hypotenuse. Negative makes perfectly good sense. We're going down. The Pythagorean theorem would say that's 3. I don't have time to work it all out for you, but that's what it would be. Pythagorean theorem. A squared plus b squared equals c squared. Now, what are we looking for? The tangent. So the answer to the question will be Opposite over adjacent. Negative 4 over 3. Opposite over adjacent. The next one is going to involve a radical, so be ready. No big deal. It's just not going to work out as nicely as the other ones. This is another tangent, so we're over there on the right side. Be the top triangle. I hope you're all getting the hang of that now. It's a positive 2/3. Quadrant 1. Opposite over adjacent. So that's going to be 2 squared plus 3 squared equals c squared. So like Geechee said, it's 4 plus 9. So it's going to be root 13. Yep, it's the same idea, we just have a radical. It doesn't work out. Now, what do I want to know about that? Cosine? 3 over root 13, or 3 root 13 over 13. Two more. All right, this one's a cosine. So be careful now. We haven't had one of these in a while. Cosines are up here. And because that's a positive number, you're going to draw it here. And the cosine is adjacent over hypotenuse. So root 7 squared plus b squared is 4 squared. A, B, C. Right? This is always C. I don't care what A and B are. This is always C. So what's root 7 squared? 7 plus b squared equals 16. So b squared equals, oh, that worked out nice. B squared is 9. So b is 3. What do I want to know? Oh, that's nice. What's the sign? Opposite over hypotenuse, which would just be 3 over 4. One more. This is a cosine. So once again, we're looking up here. Since it's a positive 3/4, I'll draw here. Everybody good with that? Bill, I don't know what you're doing, but stop it. Adjacent over hypotenuse. So 3 squared plus b squared equals 4 squared. So 9 plus b squared is 16 and b squared is 7. Which means b is root 7. I want the tangent. The tangent would be root 7 over 3. All right, now stop. Listen to me. If you haven't paid attention, the homework for this chapter is massive, okay? You should now be able to complete everything except for 8. If you have not started yet, you had better get started, because this is going to be due next week, because tomorrow we finish the chapter. And then we'll do our pre-test, and then we'll have our test.
Like early next week?
No, it'll be at least like Thursday. All right, but you need to get going on it because it's a lot. Okay.
Sure, going to the log.
All right, you're free. Go, run away, dash out. Wouldn't want to stay 1 extra minute. Heavens forbid.